Hello guys, in this video we are going to explain one more example to calculate the primitive root of a number n by using a Balyan method. In my previous video I already discussed about the Balyan method, all the 5 steps. So by using those steps I am discussing how we calculate all the primitive root of the number 25. So we can say, so this is your all the steps for the Balyan method, and now we are going to calculate all the primitive root of the number n equals to 25 here. Okay, so the first step is that we have to calculate phi of n. So the first step is that I have to calculate phi of 25. So according to the short trick method, the phi is Euler-Tuition function. So the number 25 having a factor 5 into 5, so we can represent it into 5 to the power 2. So according to the short method, the phi of 25 can be calculated as n into 1 minus 1 upon P1 up to like this. So here P1 is 5, so it will be represented as 25 1 minus 1 upon 5. Okay, so 25 into that, it becomes 5 minus 1, that is 4 upon 5, and if I cancel out this, 5 5 is 25, then phi of 25 is 20 here. Okay, now in the first step itself, after computing the phi of n, now we have to find all the k divisor of this number 20 up to phi n by 2. So what is, first of all, what is phi n by 2 here? Phi n by 2 is 20 by 2, that is 10 here. This means that from number 1 to number 10, okay, I have to find all the k divisor which have a common factor or common divisible number with this number 20, okay, with this number 20, and then those number can be represented as n1, n2 and up to nk here. So this means if I start from number 2, because 1 is an exceptional number, so from 2 and 20 having a common factor, yes, so n1 becomes 2, then 3 and 20 have a common factor, no, 3 next number is 4, so 4 and 20 have a common factor, yes, so n2 becomes 4 here. Then after number 4, 5 and 20 have a common factor, yes, so n3 becomes 5 here. Then after 5, 6 and 20, similarly we will check from 7 and 20, 8 and 20, 9 and 20, and like from this that we find all the number or like n1, n2, nk, find all the k divisor of this number phi n of phi n up to phi n by 2. So in this way we have n4 equals to 10 here. So because we have to calculate up to phi n by 2. So in the first step, we calculate phi of 25, which is 20, and then we find all the divisors like n1 equal to 2, n2 equal to 4, n3 equal to 5 and n4 equal to 10. Okay. Now in step 2, we have to select only those elements of Zn which have a no common divisor with the number 25 and put those number or those element in the new set, that set is called S1. Okay, so in the step 2, we select only those element, of Z25. Z25 means from 1 to 24. Okay, so select only those element of Z25 which have no common divisor with the number n, means with number 25, and put those selected element in a new set, that is S1. Okay, so we start with number 2. So 2 and 25 have a common divisor, no. Okay, so we put this 2 in S1, then 3 and 25 have a common divisor, no. So we put 3 in S1. Similarly, we have to check from up to 24 number. So the S1 set will become 4, 6, 7, 8, 9, 11, 12, 13, 14, 16, 17, and after that it is 18, 19, 21, 22, 23 and 24. So all the elements of this S1 have no common divisor with this number 25, and those selected elements will put it into the set S1. So this is step 2. Okay, now see what is step 3. We have to calculate n to the power nk. So in this n of k is n of 4, that is b to the power 10. mod n, so for all the values of b, okay, and select only those element of S1 for which the answer will not be equal to 1, and put those selected element into the set S2. So in the step 3, or we can say we have to compute b to the power n of k mod n for all b which belongs to set S1, and select only those elements for which these value is not equal to 1. So what is n of k? N of k is n of 4, which is equals to having a value 10. So we have to compute b to the power 10 mod 25 for all b, okay, which belong to set S1. Okay, so by illustration, only those elements for which b to the power n mod 25 is not equal to 1, we will put all the selected element in the set 2. Means if I calculate first element of S1 is 2 here. So 2 to the power 10 mod 25, it is not equal to 1. So this means that the new set S2 will contain this element 2. So similarly, we will calculate for all those element of S1 and put it into this in place of b. Means the next value is 3 to the power n mod 25, and then we can say that it is not equal to 1, so we will put it into S2. The set S2 contain the values as 2, 3, 7, then 8, then 12, then 13, then 17, then 18, 21, 22, 23 and 24. See, the set S2 will contain a less element as compared to the set S1. In the step 4 is that we go to step 2, and now we compute up to b to the power nk of k minus 1 for all the element of b which contain the set S2, and put it into the new set S3. So we will repeat this process again and again. So in the next step means step 3. Now we have to compute for b to the power n of k minus 1. So for n equals to 25, now we have to compute b to the power n k minus 1 mod n. Means in the step 2, we will calculate n4. Now we have to take n3 value. So n3 is 5 here. So this means n3 is 5 here. So we have to calculate b to the power 5 mod 25 for all b which belongs to set S2. So the first element of S2 is 2 here. So 2 to the power 5, if I calculate 2 to the power 5 mod 25, again it is not equal to 1. So we will create a new set S3 and put this number 2 into S3. So similarly, the next element of S2 is 3. So again we have to calculate 3 to the power 5 mod 25. Again this value is not equal to 1. So we will put it into S3. So in this manner, the set S3 will contain the elements like 2, 3, 7, 8, 12, 13, then element is 17, 18, 22, 23 and 24. Okay. Now the next step is for this number n25, we have to contain b to the k minus 1. Means now we will, in this step 3 we consider n3, now we consider n2. What is n2 here? n2 is 4. So this means again we have to calculate b to the power 4 mod 25 for all b which belongs to set S3. So this means first we have to calculate 2 to the power 4 mod 25. Okay, and again it is not equal to 1. So we will create a new set S4, and in this manner we will calculate all the value of S3 in the same way. So S4 contain 2, 3, 8, 12, 13, 17, 22 and 23. Okay. Now for the last of value of n1, the last value of n1 is n1. What is n1 here? n1 is 2. So in the next step, that is step number 5, now we calculate b to the power 2 mod 25 for all b which belongs to step that is set S4. So this means the first element is 2. So 2 to the power 2 mod 25, it is not equal to again 1. So we will create a new set S5. Elements of S5 is 2, 3, 8, 12, 13, 17, 22 and 23. So this is how we calculate for all the k divisor value, means n1, n2, n3 and n4. After calculating for the n1, that last set is S5 here. As a result, the set S5 contain all primitive roots, all primitive root of the number 25. So the primitive, this set is this the final answer for this number, primitive root for this number n equals to 25. Okay, so I hope you will understood this, and if you have a doubt then you can ask in our comment section. So keep watching our video. Thank you so much.